Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 638. Please turn to it, page 638. And today is our lesson number 61. Today we'll begin working on exam number 5. There are 10 exams in this book. Yesterday we finished exam number 4. Today we'll start exam number 5, as I just said. Number 1. There are 20 questions in this section. They are all of the same type. They are all multiple choice questions, which means the scale of difficulty goes all the way from 1 through 20. The first 6 or 7 are going to be easy. The next 6 or 7 are going to be medium, and the last 6 or 7 are going to be hard. Number 1, of course, is number 1 on a scale of 1 to 20. It's very straightforward. We are told that 3x plus 9 equals 5x plus 1. And the question simply is, what's the value of x? Let's find out. Subtract 3x from both sides. This positive 3x drops out with this negative 3x. And subtract 1 from both sides, so we can get rid of this 1 here. And 5x minus 3x equals 2x, which equals 9 minus 1, which is 8, and therefore x equals 4. X equals 4. That was number 1. Let's take a look at number 2. We are told the first term in the sequence is 7. Each term after the first term is determined by multiplying preceding term by m. So we take our first term, which is 7, and we multiply it by some term by some number m, and then we add p to it. And when we do that, we are told that what we get here is 15. That's our second term. What can we do here? Pretty straightforward, pretty simple. You want to make it 15. Obviously it's increasing, so there's got to be something positive here. What doesn't have to be positive, but let's try 2, see what happens. If we put in 2 here, 7 times 2 is 14, and p might be 1. I say might be 1 because we don't know yet. We'll confirm it in a second. So the second term turns out to be 15. So then we take our second term, multiply it by 2, and then add p to it, which we think is 1. And if this works out, this gives us what they tell us it is. The second term the third term according to their sequence is 31. What do we get here? 2 times 15 is 30, plus 1 is 31. You see, it works. And the one after that is going to be 31 times 2 plus 1. 31 times 2 is 62, plus 1 is 63. So it works. That's exactly what they tell us. They tell us that the series goes like this: 7, 15, 31, 63. So that's what it is. And they're asking us how much is m. M is 2. M is 2. And p is 1. They're not asking for the value of p, they're looking for value of m. The answer is B as in boy. Let's go on the next page. Number 3. Page number 639. Number 3. In number 3, we are given 2 tables. In the first table, we have 3 colors: red, white, and blue. In the second table, we have 4 sizes. We have a small, medium, large, and extra large. And the question is, how many different combinations of colors, how many different combinations of color and sizes are possible? Well, we have 3 colors. We have 3 different colors. And we have 4 different sizes. How many combinations do you suppose are possible? Obviously 12 of them. 4 times 3. You can have a red with a red small one, red medium one, red large one, or red extra large one. And similarly, we can have white small, white medium, white large, and white extra large. And similarly, we can have the same 4 combinations with the blue. There are 12 possibilities. So that was number 3. Let's move on then. Number 4. The question is asking for which of the following function is f of negative 3 greater than f of positive 3. This is read as f of negative 3. This is how it's read, f of negative 3. And what does it mean? It means value of the function when x equals negative 3. F of positive 3 would be value of the function when x equals positive 3. And our job is to locate a function where the two values are equal to each other. Let's find out, shall we? Let's look at A. In A, they tell us that f of x is equal to 4x squared. Well, if that were the case, then f of negative 3 would be 4 times negative 3 squared. But negative 3 squared is same as positive 3 squared, because negative times negative is positive. So this quantity is same as 4 times positive 3 squared, which of course is same as 4 f of positive 3. So here we have a situation where f of negative 3 equals f of positive 3. We need a situation where f of negative 3 is bigger. A is not the answer. Let's look at B. Oh, B is an interesting one. Let's do B by itself. B says f of x equals 4. How do you suppose we might plot this graph? How do you suppose we might plot this function, f of x equals 4? What this function tells us is that no matter what the value of the x is, whether x is 1 or 2 or 3 or 4 or negative 1 or negative 2 or negative 3, no matter what the value of x is, y, this is f of x is same as y, it's always 1, 2, 3, 4. It's always 4. What this function tells us is that the value of the function is always 4, no matter what the value of x is. In other words, f of negative 3 is 4, and so is f of positive 3. They are both equal to each other. As a matter of fact, all the values of the functions are equal to each other at all values of x. That's not what we're looking for. We're looking for situations where f of negative 3, the value of the function at negative 3, is greater than the value of the function when x equals positive 3. B is not the answer. Let's look at C. In C, they tell us that f of x is 4 over x, which means f of negative 3 is going to be 4 over negative 3, which in fact is less than 4 over positive 3, which is f of positive 3. We want value of the function at negative 3 to be more than the value of the function at positive 3, not less. This is not it. Let's look at D. Let's look at answer choice D. In D we have f of x equals to 4 minus x cubed. Let's see what this gives us, shall we? F of negative 3 here would be 4 minus negative 3 cubed. Now 3 times 3 is 9, 9 times 3 is 27, but because it's a negative 3, negative 3 times negative 3 is going to give us positive 9, but then when you multiply positive 9 by a negative 3 one more time, it becomes negative 27. So this boils down to 4 minus a negative 27, which is same as 4 plus 27. On the other hand, f of positive 3 is going to be 4 minus a positive 3 cubed, 4 minus a positive 3 cubed, which is going to be same as 4 minus 27. And of course here we can see that 4 plus 27 is more than 4 minus 27. And 4 plus 27 is the value of the function at negative 3. And that we found out is more than the value of the function at positive 3. The answer is D. The answer is D. You can try out E also. You'll see that E does not work in case of E because of the fact that it's fourth power. All the even powers, they will be equal to each other because negative and negative cancel each other out. Let's go to number 5, shall we? Number 5. That's it. We're done with this one. Number 5. In number 5, they tell us the force required to stretch a spring beyond its natural length is proportional to how far the spring is being stretched. Obviously, what they're telling us is that if you have a spring, how far you can stretch is proportional to how much force you exert. Obviously, proportional means the more force you apply, the more it's going to stretch. They are told that if a force of 15 pounds stretches a spring to 8 centimeters beyond its natural length, what force in pounds is needed to stretch this particular spring 20 centimeters beyond its natural length? It's a simple proportion problem. It's a simple proportion problem. Here's the force in pound, here's the stretch in centimeter, and we are told that when we apply 15 pounds, we can stretch it 8 centimeters beyond its natural length. Question simply is, how much force do we need to apply if we want to stretch it 20 centimeters beyond its natural length? Let's see what we can do. Cross multiply. 15 times 20. 15 times 20 equals 8 times 8. 8 times x. And therefore x equals 15 times 20 over 8. Divide top and bottom by 2. This 20 is going to become 10. 8 is going to become 4. Let's have one more go. 10 will become 5 and 4 will become 2. So it's 15 times 5 divided by 2. Let's find out what that is. That's 15 times 5 divided by 2. If we divide 15 by 2, 17 times 2 is 14, and therefore 15 divided by 2 is 7.5. So it's 7.5 times 5. 7.5 times 5 is same as 7 times 5, which is 35, and 5 times half. And 5 halves, we know 2 halves make a 1, 4 halves make 2, and 5 halves is going to make 2.5. So it's 37.5 is the answer. Let's see if they give us 37.5 anywhere. There you go, 37.5. The answer is E. 37.5 centimeter is going to stretch beyond its natural length if you were to exert a force of 20 pounds as opposed to just 8 pounds. I don't know if you are able to see it or not, if you were quick enough to see that 7.5 times 5, listen very carefully, okay? 7.5 times 5, I hope you are able to see right away, that is same as 15 times 2.5. 15 times 2.5. I'm going someplace with it, pay attention. Why? Because you take half of that, half of 5 is 2.5. If you divide that by 2 and you multiply that by 2, you're basically not changing anything here. So 15 times 2.5 is same as 7.5 times 5. Where does this come from? What does that have to do with anything? What I want you to see is this. I need the room, so I'm going to erase all of this work. Watch what happens. We didn't have to do any of this thing. We didn't have to do any of this thing. If you were quick enough to realize that 20 is 2.5 times 8. 20 is 2.5 times 8. How do we know that? Because 2.5 times 8 is same as 2 times 8, which is 16, and half times 8. If you have 8 halves, that's a 4. So 20 is 2.5 times 8, which means the top also needs to be 15 times 2.5. X equals 15 times 2.5, which is exactly what this is. You see? Let's go to the next one, number 6. Let's see what we have in number 6. Y, we are told, is the midpoint of x to z. Alright, so let's draw our x to z. X to z. Y is the midpoint, which tells us that x to y must equal y to z. X to y must equal y to z, which is what it means to be a midpoint. Let's see what they tell us. The first statement tells us that y to z equals 1/2 of x to z. X to z, of course, that is true. X to z is the entire distance And therefore, y to z, which is half the distance, what this exact is, which is half the distance, y to z is half of x to z. The first statement works, which means the correct answer, whatever it is, must contain Roman numeral 1 in it. Let's see what we can do with it. A, B, C, D, and E. Let's cross out the impossible answers. Any answer choice that does not have 1 in it cannot be right answer, which means any answer choice that does not have 1 in it cannot be right answer, which means we can cross out B. B says 2 only, C says 3 only, and that's about it. Let's look at second statement. I don't like second statement. I don't like the look of second statement. 1/2 x times. I'm going to skip second statement. Let's go to third statement. Third statement to me looks prettier. Okay? Third statement to me looks prettier. And I like to take care of the easy stuff first. Okay? Anything that that's annoying, don't deal with it. What I'm trying to make you understand is that, this is what I'm trying to make you understand. Okay, listen carefully. What I'm trying to make you understand is that these type of questions are what are known as 1, 2, 3 problems. They're giving you 3 statements. Our job is to find the right combination. And what most people end up doing, what I find many a times, is that they sit there and they analyze all 3 of the statements in the proper sequence, and then they find the right combination, and then they look for the answer choice which gives them the combination that they arrived at. Don't do that. That's very time consuming. Don't do that. Do one statement at a time, kill the impossible answers, and perhaps you're running out of time. Maybe you don't have the time. Maybe you have 2 more questions to go and only 2 minutes left on the clock. So do 1 or 2 statements, narrow down the odds, raise your odds, kill the impossible answers, narrow down to 2 or 3 answer choices, pick one and move on, because you don't have the time. But if you go in exact sequence, that will take you too long, especially on the hard questions. I don't want to deal with number 2. Let's look at number 3. Number 3 says 2 times xy. Xy is this part. Twice the distance of xy, we are told, is equal to x times z. Of course it's true. 2 times the distance of xy must equal the entire distance from x to z, because x to y is half the distance of the entire thing. So third statement is also true. Third statement is very easy to see. I can very easily see that the third statement is true, which is why it looked pretty. Which means any answer choice that does not have statement number 3 in it, Roman numeral 3 in it, we can kill. Let's see, what can we cross out? A says 1 only. That's not going to work. A says 1 only. And D doesn't have 3 in it. D doesn't have 3 in it. Notice how I'm showing it here, like this, as opposed to like this. This is exactly how I do it in the real exam also. I use different symbol for me to keep separate in my mind that the reason we crossed out, what this signifies, this symbol here and this symbol here, signifies the fact that the reason we crossed out B is not the same reason why we're crossing out A. A and D have been crossed out for a different reason, but the same reason. A and D have been crossed out for the same reason, because it's the same symbol. And B and C have been crossed out for a different reason, but for the same reason. B and C are the same reasons. That's what the symbols signify. Anyway, we're done. The answer is E. We didn't even have to look at statement number 2. What do you know? That's it. The answer is E. Now, for learning purposes, if you want to make sure that statement 2 is in fact not true, we can do that. Let's find out. Why is statement 2 not true? Because statement 2 did not appear in the final answer. Final answer is 1 and 3. E is the answer. Let's see what the statement 2 says actually. The statement 2 says 1/2 x to z, 1/2 x to z is the entire distance, is equal to 2 times x to y. X to y. 1/2. No, this is not true at all. Look, if you're going to take twice the distance, of x to y is this distance. If you're going to get twice the distance, twice x to y is same as x to z. It says it's equal to half of x to z. It's not true. This would have been true. Look, this would have been true. This is true. X to z, look, x to z equals 2 times x to y. But they're saying that half of that equals 2 times. This is nonsense. Statement 2 is not true. We're done. I will see you tomorrow. Well, we'll pick up from page number 640. Okay? Bye now.